Hey guys, today we're going to talk about significant figures. You need to go ahead and get out your page 2 of your notes that says significant figures at the top. You're also going to need a pen, a highlighter, and a calculator, or a pencil, whatever, something to write with. So if you don't have those things, pause the video, go get them, and then come back. Okay, if I sound kind of weird while I'm talking, it's because I just went to the dentist and my face is like numb. So that's why I might sound a little strange. Okay, so let's jump right in. Where do significant figures come from? If you remember, last time we talked about measurement and how all measurement tools have a limitation. So when we're taking a measurement, we write everything we know and then we estimate one place. So that last place, that last number, that last digit that we see is always an estimated digit. So how do we count significant figures? Okay, so I know that you guys went over this last year with Miss Love, but we're going to go over it again because it's very important all the way up to AP Chemistry, okay? So let's review it again. So non-zero integers are always significant, okay? Non-zero integers. That means anything that's not a zero, you always count as a sig fig, okay? Zeros might be significant. This is where kids get mixed up. Are the zeros significant or not? Okay, so leading zeros. Leading zeros are the zeros before non-zero digits are never significant. So what does that look like? If you have 0.03, okay, these are not significant. Not significant. So this number right here would only have one sig fig. This one would be the only significant one. Okay. Captive zeros are the zeros between non-zero digits or a digit and a decimal. These are always significant. So if I had like 401, that zero is significant. Okay, that is significant. Significant. And let's highlight that. Always significant. Captive zeros are always significant. And the last one is trailing zeros. Trailing zeros are the zeros after the non-zero digits. This is where kids get super confused. They're always significant when there is a decimal. So if there's a decimal, they're significant. If there's no decimal, it's not. Okay? So an example of that would be like if you have the number 500. Those zeros, do you see a decimal? No? Okay, not significant. Not significant. So what that means is this would only have one sig fig, and that would be the 5. Now, however, if you change that and you were to put 500 and you put a decimal at the end, or a decimal and another 0 at the end, these are all significant. And now this would have 4 sig figs. So this one only has 1 sig fig, this one has 4. These zeros become significant when there's a decimal. Okay, now just a quick reminder, you guys should be writing and highlighting everything that I'm writing and highlighting. Your paper should look like my paper. You shouldn't just skip over stuff, okay? So make sure that you are doing that, okay? Okay, exact numbers. So things that are counted, things that are definitions, pi, things like that are considered to have an infinite number of sig figs. Okay, so things that are not measured, but things that are counted, okay? I'll put that. So these things are not measured. So for example, they're not measured, they're counted. They're exact. So if I'm trying to figure out, okay, how many kids are in my classroom? There's 23 kids in my classroom. That has an infinite number of significant figures, okay? Because I can't have half of a kid. I can't have 0.76 of a child, right? So exact numbers have an infinite number of sig figs. They're all significant because none of them are estimated. Okay, so let's do some examples. How many sig figs? So anything that's not a 0 is automatically significant. So the 2 is automatically significant because it's not a 0. These zeros here look like leading zeros. Leading zeros are never significant. So that means that this only has 1 sig fig. Okay, that 2 is the only significant digit there. Okay, here we have a couple non-zeros. So the 3 and the 8 are significant. Is the 0 significant? Let's see. That's a captive 0 because it's in between 2 non-zero digits. So captive zeros are always significant. So this has 1, 2, 3 sig figs. Okay, this has 3 sig figs. Okay, Again, I have my non-zero digits. The 4 is significant, the 1 is significant. Now I have to look at the zeros. These zeros are trailing. They're on the end. It says trailing zeros are always significant when there is a decimal. Do you see a decimal here? I do not. Therefore, those are not significant. Therefore, these are my only 2 sig figs. Okay? All right, here my 5 is significant, my 1 is significant. Let's look at this 0. This 0 is a captive 0. Captive zeros are always significant. And this one's a trailing 0. Trailing zeros are only significant when there's a decimal. Is there a decimal? Yep, there sure is. Therefore, this one's significant as well. Therefore, I have 1, 2, 3, 4 sig figs in that number. Okay? So that's how you count and figure out how many sig figs you have. Now, when this applies to doing math, sometimes kids get confused because there are different rules for figuring out how to round your answer when you're adding and subtracting versus when you're multiplying and dividing. Now, when you're adding and subtracting, you don't look at sig figs. So write that down. Don't look at sig figs. Look at decimal places. Now, I'm just going to give you a little caveat here. How often are we going to use adding and subtracting? Not often. We hardly ever use this in chemistry. This one we're using 99% of the time. So I'm just going to tell you the rules for adding and subtracting, and that way you know them, and we might run into them once or twice this year. But then you can almost pretty much forget about them because we won't use them very often at all, okay? But I want you to know what the rule is just in case you do encounter it. So you take the two numbers, so let's add them together. I'm going to get out my handy dandy calculator here. That's 13.21 plus 17. Okay, I'm going to write out my unrounded answer. My unrounded answer is 30.21. Now I need to figure out how to round it, so I have to go by the least precise, okay? Answer must have the same number of places after the decimal as the least precise. This has 2 numbers after the decimal. This has no numbers after the decimal because there's no decimal. Therefore, I have to go with the least precise because this has no numbers after the decimal. This one can have no numbers after the decimal. So this is a 2. Because it's less than 5, it's not going to bump this up. So I would just round that to 30 and just leave it like that. Okay. Let's try this one. I'm going to subtract those in my calculator. Let's see what we get. 13.1 minus 4.2134. And I get this. So I'm going to write out my unrounded answer. Oops, unrounded answer first. Okay. And then I need to figure out how to round it. This has 1 number after the decimal. This has 4 numbers after the decimal. I have to go with the least precise because this only has 1. I can only have 1 number after the decimal, the 8. However, I have to look at the number right next to it. Since it's more than 5, or if it's 5 or above, it's going to bump it up. So it's going to be 8.9. And that's how I'd round that. Okay, so now you know the rules for rounding when we are doing adding and subtracting. You can pretty much forget about it. This is the important one. Star, star, star. This is the one that we're going to use 1,000 more times, okay, than the adding and subtracting. Okay, answer must have the same number of sig figs as the least precise. So when we do 4 times 21, 4 times 21, I get 84. I get 84. However, this has 1 sig fig, this has 2 sig figs. Because this one only has 1 sig fig, I can only have 1 sig fig in my final answer. How do you make 84 into 1 sig fig? Well, you just have to round it down to 80. Because this is less than 5, it's just going to be 80. I know it's weird. Because now this only has 1 sig fig. This 0 is not significant because there's no decimal. Okay. All right, let's do this one. So I've got, oops, my paper went crazy. All right, 6.32 divided by 7.1. All right, I get this big long number. I'm going to write out a big chunk of it. All right, that's my unrounded answer, right? Now, I need to figure out how to round it. This has 3 sig figs. This has 2 sig figs. So I have to go with the least amount. Because this one has 3 and this one has 2, my answer can only have 2. So I'm going to round it. Now, remember, the leading zeros don't count, so I can keep this. and then I'm going to go 8, 9, and then leave it like that. Because the 0 is not going to bump the 9 up. It's just going to stay like that. Okay. Okay. Let's talk about scientific notation. Scientific notation is a method used for expressing very large or very small numbers. Okay. It's made up of 3 parts. You have a coefficient, a base, and an exponent. So your coefficient is this guy here, everything before your times sign. So this is your coefficient. Your base is always going to be 10. Okay, always 10. And then your exponent, of course, is your exponent, your little baby number up there. Okay. So here are the rules. Your coefficient always needs to be between 1 and 10. Okay, so this guy here, the coefficient, should always be between 1 and 10. The base is always 10. And the exponent shows the number of decimal places that the decimal needs to be moved to change the number to standard notation. Okay, so a negative exponent means that the decimal is moved to the left when changing standard notation. So if you have a really, really big number, that means you're going to have a positive exponent when you change it to scientific notation. And if you have a really, really, really small number, like less than 1, that's what I mean by really small, then it's going to have a negative exponent when you turn it into scientific notation. Let's practice. Change the following numbers into scientific notation. So this one. So what we have to do is we always have to move the decimal until there's only one number to its left. Screech. We only moved it one time, so it's going to be 6.57. And you always move it until there's just one number to its left, because that ensures that it's between the numbers 1 and 10. Okay? And then it's always going to be times 10 to the something. And then, is this number big or small? Well, is it less than 1 or more than 1? Well, it's definitely more than 1, so it's kind of a bigger number. So we know our exponent's going to be positive. We only moved it one spot, so it's going to be times 10 to the first. Okay? Okay, now let's move this number into scientific notation. Just by looking at it, I can tell this is a very small number. It's less than 1, so I know that it's going to have a negative exponent. Without even doing anything, I know it's going to be times 10 to the negative something. So let's move it until there's only one non-zero digit to its left. Screech. Okay, right there. So that's 5.45 times 10 to the negative. How many times did I move it? 1, 2, 3 times. Ta-da! Okay, this one. This one, I don't see a decimal anywhere on here. That's because it's a whole number. So the secret invisible decimal is always at the end right there. So I'm going to take it and I'm going to move it until there's only one digit to its left. 1, 2, 3, 4, 5, 6, 7. I moved it 7 times. So it's going to be 2.245 times 10 to the 7th. And that's going to be a positive exponent because this is a very large number. Okay. Okay, now what if you want to change it back from scientific notation back to standard notation? Okay, so what you do is you move the decimal however many times it says. If it is a positive number, you move it to the right to make it big. If it's a negative number, you'll move it to the left to make it small. Okay, so this is a positive 4, so I'm going to go 1, 2, 3, 4. And in those empty places, I'm going to put zeros. So it's going to be 8, 8, 5, 0, 0. Okay. All right, let's take the decimal and move it 2 times. I'm going to move it to the right because it's positive. I know it's going to be moved to the right to make it a bigger number. So I'm going to go 1, 2. Stuff right there. So that's going to look like that. Okay. Okay, and the last one, it's a negative 3 because it's a negative number. I know I need to move it to the left because it needs to be less than 1. So I'm going to go 3 times to the left. 1, 2, 3. So it's going to be 0.003400, and for convention, I like to add a 0 to the front to make it look pretty. Okay? Okay, last thing I want to say. So when you're putting numbers in scientific notation into your calculator, some kids get confused by this. There's a couple different ways that you can do it. I like to use the E button on this calculator. Guys, this is a wonderful calculator to get. If you have one of these, I would suggest using it for physics and chemistry. If you don't have one of these and you have a different scientific calculator, great. I already told you guys kind of the philosophy on calculators. You can't use your own graphing calculator on comps or pre-comps. I think this was maybe a $10 calculator, okay? So this is how if I were to encounter a number like this is how I would put in the calculator. I would do 2.54, and then I would press second, and then this button here, because it's hard to see, there's a little EE above there. And then the E takes the place of times 10 to the. So it takes the place of all of this, the times 10 to the. So I don't need to put a caret, I don't need to put anything, I just put 5. And that's it. Okay? And that's how I would get that number in my calculator. You could also do it like this, 2.54 times 10 to the 5th. Like that. You get the same thing. The problem is with this, you often need to put it in parentheses if you're doing a calculation with it. Okay? So I want to emphasize, so I have that all written out here. E takes the place of times 10 to the. So we need to practice because so many kids struggle with putting numbers in scientific notation into their calculators. And don't just sit here and watch this video. You really need to practice this with your own calculator. So if you don't have your calculator in your hand right now, put your calculator in your hand because you need to practice this to know how to do it. So I'm going to multiply these two numbers. So I'm going to go 2.54. I'm going to use my E button. So remember, E takes the place of all that. So I'm going to go E5. Okay, and then what I like to do is I like to press enter in between. If I just press enter, and then if I press just times, it stores it in there for me. So times 7.16 E3, and I get this big long number. So I'm going to write out my unrounded version first. And then let's figure out how many sig figs we need to round to. Well, this has 3 sig figs. And this has 3 sig figs. Now, when you're looking at a number in scientific notation, you just look at the coefficient to figure out the sig figs. This has 3 sig figs. This has 3 sig figs. So my number has to have 3 sig figs. So I'm going to look at my 4th sig fig over. And there's 2 different ways I could do this that are technically correct. So I can go 1, 8, and then this 8 would bump this 1 up to a 2. So this would be 2. 0, 0, 0, 0, 0, 0, 0. Okay, I think I have enough zeros in there. So technically that's correct, rounded correctly, because this only has 3 sig figs. However, you know, scientific notation, this is why it exists. This number is ridiculous to write out, right? So you could write it out as 1.82 times 10 to the, let me see, how many times did I move it? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th. Okay. All right, let's do one more and then we'll be done. We're just going to divide the numbers now. So I got 2.54 E5, and then I'm going to divide by 7.16 E3, and I get this number here, 35.47486034. And then, let's see, I have 3 sig figs here, 3 sig figs here. I need to round to 3 sig figs. So, look at the 4th one over. The 4th one is a 7. That's going to bump that up. So, it's going to be 35.5. That would be my final answer. And if you really wanted to move that to scientific notation, I mean, technically you could write it as 3.55 times 10 to the first. That's equally correct. Both of these are equally correct. Okay. All right. So practice that, put it in your calculator, see if you get the same answer I'm getting. If you're not getting the same answer I'm getting, maybe you're trying to do this method and you're forgetting your parentheses. But if you don't practice, you'll never know how to do it. So make sure that you know how to do it in your own calculator, and go ahead and do the assignment and send me a chat if you have any questions. Good luck.